All right. Just to remind you guys what we've been doing last time and this time. We've been talking about taking the derivative of products, quotients, and chain rules. So let's just remind ourselves of the rules you're supposed to have memorized. So, we have something called the product rule. If you got y is equal to f of x times g of x, then y prime is equal to f prime of x times g of x plus f of x times g prime of x. Now, I know if you actually watch the, solutions to the problems in Hawks, also if you read the textbook, and hopefully you're doing that on your ebook and all that other good stuff, the folks at Hawks would write this f of x times g prime of x plus f prime of x times g prime of x. It's the same thing when you do plus. It doesn't matter which one goes first, because a plus b is b plus a. I always write it like this because in terms of the formula, that's great. What I really want you guys to memorize is the words. What is the product rule? It's derivative of the first times the second plus the first times derivative of the second. And since that's my words, that's my math poetry to try to get you guys to memorize this stuff, I write my formula the same way. It's derivative of the first times the second plus the first times derivative of the second. That just kind of flows with the words. That's the product rule. Quotient rule is y equals f of x divided by g of x. Then my derivative is going to be, you take the derivative of the top, f prime of x times g of x minus f of x times g prime of x divided by g of x squared. And again, when I'm doing the quotient rule, my goal here is to memorize this. And I'm also trying to catch you guys a pattern. So if you notice, I'm using the exact same pattern as the product rule, but instead of a plus, it's a minus, and then you got the divide by g of x squared. So in terms of that same light, the Hawks will type it up slightly different. They'll do the g of x times f prime of x. That's got to be first because it's a minus, times g prime of x times f of x. And they just put them out of order. Who cares? Divided by g of x squared. But I write it like this, and then my words also. Again, what I'm trying to get you guys to memorize, because you saw right at the end, we were doing these wonderful combination rules. Okay? So it's the derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. And that's from the top bottom versus the first second, but it's the same pattern except with the minus over the bottom squared. So again, I'm trying to get you guys to easier way for you guys to actually get this stuff in your brain. And then the last one that we talked about last time was the chain rule. And the chain rule was this. There's a couple of different ways you can look at it. We got y is equal to f of g of x. Then y prime is equal to f prime of g of x times g prime of x. And again, the words that I used for the chain rule, you had to look at it from an outside-inside perspective. It was the derivative of the outside function. The inside stayed the same, times derivative of the inside. And the other way that we actually wrote this stuff up was this. We also looked at it from an extended power rule perspective. And that extended power rule, which is part of that chain rule, is anytime I got y is equal to some function f of x raised to an n power, which a lot of the times is what you're going to see, then your derivative is going to be, take derivative of the outside, the n pops out front, the inside stays the same, raised to the n minus 1 times derivative of the inside. So that's, again, the actual, what the chain rule is going to look like in that extended power rule version of it. Now, because we covered this chain rule stuff on Friday's class, I did want you guys to notice what I did do. Now, I told you I was going to probably do this, and I did. So if I go over here to my Canvas page and then log into Hawks, the lecture for section 3.2 is still open. I made it due like on Wednesday or something like that, just to give you guys, or Tuesday. Go ahead and get it done if you haven't, please. So go ahead and get the darn thing done. But I did extend this a little bit just to buy you some more time. Again, the biggest problem with this stuff is typing it in. So take your time in typing it in, because whether you clean it up or not, Hawks is going to take it either way. But if you don't clean it up, you got to be very adamant about how you put the parentheses on it. And if you also notice on that last quiz I gave you guys, which is on the product rule and quotient rule stuff, that I actually gave you an extra attempt because a lot of people were having some issues in typing it up. Because if you leave off of parentheses, instead of times -7, it becomes -7 without the parentheses around it. And so it makes a difference in terms of your answer, and it also makes a difference whether you get it right or wrong. So take your time on typing this stuff in. Parentheses around the top, parentheses around the bottom, minus the parentheses around the top, times parentheses around the derivative of the bottom, all over parentheses around the bottom, squared. I mean, you got to be very adamant about that. And put parentheses around your numerator and parentheses around your denominator. All right, so today we're moving on, and we're in section 3.4a, which is on intervals of increase and decrease. All right. So let's understand the main idea here. First off, increase. What do you guys think of when you think of the word increase? Going up. Right, your words. Going up. And in terms of a graph, going up, you read a graph from left to right, we're talking about looking something like this. It is, quote, going up. Now, putting this into a context, we've been taking the derivative. The geometric representation for the derivative is the slope of the tangent line. You've been personally programmed by me. Slope of the tangent line. But to go up, as you read it from left to right, we're talking about the slope, and M, representing that symbol for slope, is going to have to be greater than 0. It's going up. It's a positive slope. The slope is positive. When you have a positive slope and you graph a line, the line always goes upward. Does that make sense? Now, so in tying these two concepts together, the idea of going up, which means the slope is positive, and this concept of derivative representing the slope of the tangent line, so we're talking about a function is increasing. A function is increasing when the derivative is greater than 0. That's your main idea right there, defining the concept of an increasing function. When the derivative, and I'll call him f prime of x, is greater than 0. And similarly, if we were talking about decreasing here, decreasing means we are, quote, going down. From a line perspective, that means as you read a graph from left to right, it goes down. This means your slope is less than 0. This is your slope is going to be negative. Again, tying it into the concept of the derivative, which represents the slope of the tangent line here, we're talking about a function is decreasing when f prime of x is less than 0. Now, what do we mean when we say a function is increasing in terms of this idea of a point going up? We're talking about if you've got 2 points, x1 is less than x2. If we're talking about increasing, when you plot them, x1 and x2, it's increasing means that f of x1 would literally be less than f of x2. That's what it means to be increasing. As I give you 2 points, x1 is less than x2. If you read it from left to right, here's like x1 point here, here's the point x2. When you plot them, f of x1 will be smaller than f of x2. However, in terms of decreasing, I would give you 2 points, x1 and x2, and x1 came first, so it's less than x2. Then you got decreasing when f prime, f of your y coordinate x1 would literally be greater than f of x2, okay? These is what we're talking about in terms of the concept of decreasing. Your x1 point is right here, here's your x2 point. When you plot them, x1 in the terms of y coordinates is going to be bigger than your x2 y coordinate. Now, the concept is easy. Let's talk about the math behind it before I actually start on the lecture notes and stuff like that. So, let me go to a different page here. Slide this thing up. Now, what we're going to be doing is actually trying to figure out when a function is increasing or decreasing, where we're going to take the derivative and we're going to have to set it to be either greater than 0 or less than 0. Okay? Because right when it's equal to 0, when a function f of x is, when a function f of x has its derivative f prime of x equal to 0, we're talking about f prime of x actually equal to 0. What does it mean for the derivative or the slope of the tangent line to be equal to 0? This is the idea. The idea is that that slope of the tangent line is equal to 0. When you have a slope that's equal to 0, what kind of line do you have? Very good. You have a horizontal line. Horizontal, and this would be a tangent line. So, because the horizontal lines are neither increasing nor decreasing. That's what horizontal means. So the first thing we're going to have to do is identify where we actually have this horizontal tangent line. So, here is where we're going with this stuff. So before I work with the derivatives and things like that, here we go. I'm just going to give you a function. Here it is, x squared minus x minus 20, and I want to know where that guy is greater than 0. Here is the idea of the math. We'll put the calculus into it in a second. How do you solve this? Now, this goes back to your college algebra, high school algebra 2 days, math 3, or whatever you guys call it these days. How do you solve x squared minus x minus 20 to be greater than 0? How do you solve that? Well, first thing you do is you're going to factor it and set it equal to 0 first. So you're going to call this guy name. This is going to be my function here, whatever it is. I'll call him f of x. There's my favorite letter there. F of x. And the first thing I'm going to do is I'm going to take f of x, which is this x squared minus x minus 20, and I'm going to first set it equal to 0. And to solve this, I have to factor, right? So I'm going to factor it. Being a quadratic. Now, if it's linear, you can put the constant one side and divide through, but this is quadratic, so I'm going to factor it. How does x squared minus x minus 20 factor? X, what times what is 20? That differs by 1, 5 and 4, and because it's a minus, opposite signs, because the middle term is negative, the bigger number 5 is going to get the negative, the plus is going to be on the positive, equal to 0. Then you set each factor, x minus 5 equal to 0, and x plus 4 equals 0, and then you solve. X equals 5, and x equals negative 4. These are your 2 points if you're talking about, and again, we're just talking about a function here, but if I'm talking about this derivative function, this is where the tangent line would have a horizontal line at, because that's where the derivative is equal to 0. But that's not the question here. The question is, when is this function going to be greater than 0? Anytime you're solving for these more complex equations and it's an inequality, greater than 0 or less than 0, you're going to do a number line. This is how you solve it, how we teach you guys to solve it way back when in Algebra 2, college algebra, pre-calculus, whatever. You're going to draw a number line and label this number line. This is the function f, not derivative, this is this function I gave you here. And I'm going to put these 2 points on this number line in order, because this is a number line. Here's negative 4, and here's 5. Okay? These 2 zeros will subdivide your number line, in this case, into three parts. It'll be more or less number depending on the number of zeros you get for this problem. So we got three different parts, and what we're going to do here is we're going to do test values. Pick a point somewhere between negative infinity to negative 4. I choose negative 5. And I'm going to plug negative 5 into my original function, x squared minus x minus 20. This will be negative 5 squared minus negative 5 minus 20. Negative 5 quantity squared is 25. A minus makes it plus 5 minus 20. 25 plus 5 is 30. Minus 20 is 10. I don't care what the number is. What's the sign of it? It's a positive number, so everybody in this interval is going to be positive. Because at negative 4 is where it's 0 at. Now I'm going to pick a number between negative 4 and 5 and do another test value in this interval. And you've got to test the values. Don't just assume it's going to always alternate. A lot of times they do, but not always. So I'm going to test the value. And since I'm picking any number between negative 4 and 5, I'm going to use my brain. I'm going to pick the easiest number possible, 0. And I'm going to plug 0 into my function because 0 is in this interval. Okay? So I chose 0, and I plug 0 into my function, which makes it 0 squared minus 0 minus 20. That's equal to negative 20. I don't care what the number is. It's negative. So everybody in that interval is negative. Does that make sense? And then I'm going to do one more. There's an interval over here from 5 to infinity. I choose 6. And then I'm going to plug that 6 into my equation. This will be 6 squared minus 6 minus 20. 6 squared is 36 minus 6 minus 20. 36 minus 6 is 10. Minus 20, 36 minus 6 is 30. Minus 20 is 10. Kind of jumped the gun there. But don't care what the number is. The fact is, it's positive. So everybody in here is positive. So now, once I got my number line set up, I want my answer. And the answer is traditionally in interval notation, and it's going to come right off the number line. We were looking for, look at the equation, when this function x squared minus x minus 20 is greater than 0. Greater than 0 means what? Positive. Where's this thing positive at? It's positive from negative 50 up to negative 4 and from 5 to infinity. And here's the deal. Because eventually we're going to talk about this concept of increase and decrease, this will always be a greater than or less than, never equal to. And because of that, we do not want these points at negative 5 and negative 4 and 5 in our interval because that's where they're equal to 0. This would be greater than. So we always use open parentheses with this stuff. So the answer is negative infinity to negative 4 union 5 to infinity. This is the interval from negative infinity to negative 4 union 5 to infinity where this function x squared minus x minus 20 is actually greater than 0. And this is how you show your work. Does that make sense? Okay. I want to do one more before we get into the problems of the day. This was a classic quadratic polynomial type of thing here. What if I gave you this? 3x plus 6 divided by x minus 5. There we go. And I want to know where this function is going to be less than 0 just to change it. Okay? So this is what I want to find. This 3x plus 6 divided by x minus 5 is going to be less than 0. Now, the first thing I want to find on this particular, I'm going to call this guy a name. I'll call him g of x, whatever this function is called. Give him a name, whatever. Okay, first thing, because this guy is a rational expression, aka a fraction, I got problems. And I got to make sure I omit those problems. So, the first thing I want to do is identify the problem point. Problem point. Where's my problem point? Because this guy's a fraction. See, this guy was a quadratic. It doesn't have any problem points. Domain's all the numbers on this guy. This guy has a problem point. This is why we did all that stuff in the chapter 5, that domain stuff. What problem point is this? Well, because it's a rational expression, aka a fraction, it can't divide by what? 0. So I'm going to take this denominator, which is the x minus 5. I'm going to set it equal to 0 and solve. X equals 5. This is my problem point. And I'm going to identify that and make sure I put an open circle on that guy because I cannot officially have x being equal to that 5. Does that make sense? So I'm going to go ahead and draw my number line out here. And here is 5, and I'm going to go ahead and omit him because that's a point that doesn't even exist. Does that make sense? Now the other one is I'm going to find my zeros. To find the zeros, I'm going to take my equation, 3x plus 6 over x minus 5. Instead of being less than 0, I'm just going to set it equal to 0. Now granted, this is a fraction, a rational expression, but what I'm going to do to solve this guy is I'm going to multiply both sides by my common denominator to get rid of my fractions. Does that make sense? With equations, I get to do this. I'm going to multiply both sides by x minus 5. What I do to one side, I do to the other. And you'll end up getting, that this part will end up canceling, and you get just the numerator equal to 0. 0 times anybody, 0 times x minus 5 is still 0. So, honestly, when you got a fraction, you set the denominator equal 0 and omit that. And then to find the zeros, you just set the numerator equal to 0, and this will give you your zeros. So I'm going to subtract 6 from both sides. That gives me 3x equals negative 6. I'm going to divide by 3 on both sides, and I'm going to get x equals negative 2. Does that make sense? And there's my 0 point. This is the 0, but we want to omit the 0, because remember, we're originally trying to find when this guy is less than 0. So I'm going to put it on the number line. There's 5, so negative 2, the 0 is here. So this is my 0 point, and this is my D and E point. Okay? And now, once again, it sets up my number line into 3 different intervals. So with fractions, rational expressions, I'm going to get 2 different kinds of points. I'm going to get where the denominator doesn't equal 0, where the denominator is equal to 0, which is a point that does not exist, because you can't divide by 5 in this problem. And then I'm going to get the 0 points, just like up here. These had 2 0 points. This one I'm going to put the 0 point, and this one will also have a special point that does not exist, if you get that. Now, what do? I'm going to do my test values. Pick a number in each interval. I pick somewhere between negative infinity and negative 2. I choose negative 3. So g of negative 3, plug it in. This will be 3 times negative 3 plus 6 over negative 3 minus 5. 3 times negative 3 is negative 9 plus 6 over negative 3 minus 5. Negative 9 plus 6 is negative 3. Negative 3 minus 5. Negative 3 minus 5 is negative 8. And clean it up. What is negative 3 divided by negative 8? 3x. I don't care what the number is. It's positive, so everybody in that interval is going to be positive. This is how you solve an inequality. That's just not 3x plus 2. If it's linear, knock yourself out. But this is not linear. We're talking about quadratics, polynomials. We're talking about rational expressions. You got to do this number line bit, and you're going to have to find your zeros, find the points that does not exist, put them on a number line, and do test values. Pick a number between negative 2 and 5 and use your brain. Good choice. 0. So, g of 0 would be 3 times 0 plus 6 over 0 minus 5. 3 times 0 is 0, plus 6 is 6. 0 minus 5 is negative 5. Negative 6 divided by negative 5 is negative 6/5. I don't care what the number is, it's negative. So everybody in that interval is going to be negative. And then I'm going to pick a number bigger than 5. I choose 6. Plugging it in, that'll be 3 times 6 plus 6 over 6 minus 5. 3 times 6 is 18, and 18 plus 6 is 24. 6 minus 5 is 1. 24 divided by 1 is 24. Don't care what the number is, it's positive, so this guy is positive. So now, we got to write out our answer. And traditionally, with these answers, we want them to be in interval notation. So in interval notation, where is the solution? It is between, and always open parentheses, because you don't want to include the 0, because it's not equal to 0, and you surely don't want to include a point that doesn't exist. So the answer where it's negative, less than 0 means negative, is between negative 2 and 5. And that's my answer. Does that make sense? Did I lose you guys anywhere? This is how you solve inequalities. So let me put 2 and 2 together. What we're really after with this stuff. Again, just to remind you, before we get into our notes and stuff like that, We're after the idea of a function is increasing means the derivative is greater than 0, and a function is decreasing means the derivative is less than 0. What we're going to do is take the derivative of some function and then set it either greater than 0 or less than 0, and then do this number line trick that we were doing here. Does that make sense? This is the idea of basically putting two different kinds of math together. So, this is what section 3.4a is all about. So let's do some other problems here. All right. Obviously, the objective here is to identify intervals of increase and decrease of a particular function. And our function we're going to be focusing on is the derivative. Okay? So, here's the idea. Suppose that you have a function of f, which is defined on an interval between a and b. F is blank on interval a and b if x1 is less than x2 implies that f of x1 is less than f of x2. Well, when f of x1 is less than f of x2, it means it's going up. So we're talking about it is increasing here. And f of x is blank on a, b. F x1 is less than x2 but implies that f of x1 is greater than f of x2. F of x1 being greater than f of x2 means it's going down. That means it's decreasing. Okay? Positive values for the derivative indicate what kind of slope. Positive values for the derivative means you're going to have a positive slope. For all the tangent lines which may occur imply that the function is what? When you have a positive slope, you are what? Increasing. Negative values for the derivative indicate a negative slope. Because remember, the derivative is the slope of the tangent line, so just kind of tying those two concepts together. So when the derivative is values, negative values for the derivative indicate you have a negative slope for the tangent lines, which turn imply that the function is decreasing. Suppose that f is a differentiable function on the interval between a and b. If f prime of x is greater than 0 for all x in a and b, then f is what? When your derivative is greater than 0, what do you call that? Increasing. Means that the function is going to be going up. And if f prime of x is less than 0 for all x in the interval between a and b, f is decreasing. So here's the main idea here. To figure out when the original function is increasing or decreasing, it's where the derivative is greater than 0 for increasing and the derivative is less than 0 for decreasing. So you're talking about the derivative being greater than 0, that means the original function f is increasing. And when the derivative is less than 0, means the original function f is decreasing. So they're tying the two concepts, the original function with the math on the derivative. Okay? And here's another one, so always remember this. The values of x for which the function is increasing or decreasing always presented as open intervals. So you don't have to worry about, should I use a bracket or parentheses? Always use a parentheses on this stuff. Open interval means we're going to be using parentheses with this stuff. Does that make sense? So, here's your first problem. Now, this one again is on the www.hawkstv.com. So, on your when you go to hawkstv.com and look at that example, they do one very similar to this, and hopefully you're watching that stuff and taking notes on that one. Here's a problem that is very similar. Let's see what it says here. It says this: given f of x is x cubed minus 12x plus 1. Find all the values that correspond to a horizontal tangent line. What does it mean? Let's tie it together. A horizontal tangent line. We just talked about that a few seconds ago. Horizontal tangent line means what? What's 0? And the slope is also known as the, okay, derivative equal to 0. You got it. Write it up. Just putting it all together. Horizontal tangent lines mean we're going to take this derivative and set it equal to 0. So let's do that. So f of x is equal to x cubed minus 12x plus 1. That means f prime of x is, what's the root of x cubed? 3x squared minus derivative of 12x is 12. Now, we're going to set, there's my derivative, we're going to set it equal to 0 and want to solve. Well, the first thing I'm going to do with this guy is, I'm going to factor it. I can factor out a 3, and that would leave me with x squared minus 4 equals 0. And because it is a difference of squares, x squared minus 4, when I solve this guy, so my f prime of x factoring it would be 3 times x plus 2 times x minus 2 equals 0. And then I set each factor that has an x in it. Remember, you're solving for x. Each factor has an x in it. X plus 2 equals 0, and x minus 2 equals 0. You set each factor equal to 0 and solve. And when I solve, subtract 2x equals negative 2. X minus 2 equals 0, so I add 2 both sides, x equals 2. My answer is x equals negative 2 and x equals 2. Those are the, this happens to have 2 points here where the this function f of x equals x cubed minus 12x plus 1 has horizontal tangent lines. Does that make sense? Don't lose anybody there. Because you got to find those equal to 0 parts first, because that's going to help me set up my number line for the part B down here. But let me just comment, because I know people are thinking in the back of their mind, Taylor, do you have to do all that work to get that answer to plus or minus 2? Well, no, I didn't. There's another way I could do that, but remember, this is calculus class, and factoring is really awesome here. But you could have done this. I could have added 12 and then divided by 3, and that would have given me x squared is equal to 4. But then, what do you got to do to get rid of a square root? I screwed that up. What do you got to do to get rid of a square? Thank you. Take a square root. But when you introduce a square root, you got to do plus or minus. Don't forget that, and that'll give you your same answers. Okay, a lot of people just do square root, but the answer's going to be 2. You're missing one. When you introduce a square root in a problem, you got to put plus or minus. And you're more than welcome to do it that way if you wanted to. But practicing your factoring is always a good idea, and so I decided to do it this way. Now, here we go. Use the values from the problem above to find the open intervals, like you have an option here, on which the function is increasing and the open intervals in which the function is decreasing. They want to know where the function is both increasing and decreasing. Okay? So, we got our derivative. F prime of x is equal to 3x squared minus 12. I'm going to go ahead, and anytime you hear the words intervals, you listen to that, because you're going to hear it a lot in this class. When you hear the word interval, find the intervals of increase, decrease, you're going to draw a number line. That word interval means draw a number line, okay? And on this number line, I'm going to put my horizontal tangent line point, or my zeros, where the derivative is equal to 0. It is at negative 2 and at 2. And then I'm going to do test values. And again, I'm going to label this guy. This is a derivative number line. So I'm going to pick a number less than negative 2. I choose negative 3. So f prime of negative 3, I'm going to plug negative 3 into my derivative. 3 times negative 3 squared minus 12. Negative 3 squared is 9 times 3 is 27. And 27 minus 12 is what, 15? I don't care what the number is. What's the sign of it? Positive. So everybody in that interval is going to be positive. Now pick a number between negative 2 and positive 2 and use your brain. Good choice. 0. This will be 3 times 0 squared minus 12. That's equal to negative 12. It's negative. So everybody in that interval is going to be negative. And then pick a number bigger than 2. I choose 3 because it's easier. F prime of 3 would be 3 times 3 squared minus 12. 3 squared is 9 times 3 is 27 minus 12. We're back to 15 again. It's positive, so everybody in the interval is positive. So to answer their question, what intervals is it increasing on? Increasing means what? Positive first derivative. Positive derivative. Where's my positive derivative at? What interval? Remember, this arrow represents negative infinity. So this would be negative infinity to negative 2 union 2 to infinity. You're identifying the intervals at which the derivative is positive. For decreasing, you're going to identify the intervals which the derivative is negative. Where's it negative at? Between negative 2 and 2. And there is my answer for the question. Does that make sense? So yes, there's a lot of steps involved in this thing, but it's going to tell you where it's increasing, where it's decreasing. And you look at this and you go, what real purpose does this have? Well, all right, I would like to know when my cost is going up and when my cost is going down, and identifying spots like this. That's what this is telling me. My cost is going up, that means my derivative is going to be positive. My cost is going down, better, is when my derivative is going down, negative. Does that make sense? So there's a lot of applications with this type of stuff, and that's what we're going to hit to, but first, we've got to show you how to do the math. So let's do some practice problems here. All right, so notice how they word the problems here. Find all values of x that correspond to the horizontal tangent lines, and then find open intervals which the function is increasing and open intervals where it's decreasing. All right, my first problem is this. F of x equals 2 minus 4x minus 2x squared. Anytime you hear the words, find intervals of increasing and decreasing, and this is the words I'm going to be using. Find the intervals of the given function, find the intervals where the function is increasing and decreasing. Function increasing and decreasing, first thing you got to do is you got to take derivative. Derivative of 2, 0. Derivative minus 4x is negative 4. Derivative minus 2x squared is minus 4x. So derivative of 2 minus 4x minus 2x squared is negative 4 minus 4x. Does that make sense? Okay, the next thing I'm going to do is I'm going to find my 0 points. That'll be the numbers I put on my number line. So I'm going to set my derivative equal 0. I'm going to add 4. So that gives me negative 4x is equal to positive 4. I literally added 4 to both sides. And then I'm going to divide by negative 4. And I get x equals negative 1. 4 divided by negative 4 is negative 1. So, and I'm going to draw my number line. I'm going to put that number on there, negative 1. And I'm going to label this number line as an f prime number line. This is my derivative, and we're trying to figure out whether the derivative is going to be positive, increasing, or negative, decreasing. So I put my number on there, and then I'm going to pick some test values. Pick a number less than negative 1. I choose negative 2. I'm going to take f prime of that negative 2. So I'm going to plug it in my derivative, negative 4 minus 4 times negative 2. Negative 4. Negative 4 times a negative 2 is a plus 8. Negative 4 plus 8 is positive 4. Don't care what the number is, it's positive. So everybody in that interval is going to be positive. Now, pick another test value on the right next interval. Pick a number, use your brain, that is bigger than negative 1. Good choice, 0. So f prime of 0 would be negative 4 minus 4 times 0. 4 times 0 is 0. Negative 4 minus 0 is negative 4. That is negative. So everybody in that interval is negative. So therefore, to answer the question, we want the intervals of increase and the intervals of decrease. Where is this function increasing at? It is increasing, representing the arrow to the left is negative infinity. It's increasing between negative infinity to negative 1. Always use open parentheses on this stuff. And it is decreasing on the interval between negative 1 and infinity. Does that make sense? Try this guy. Same directions here. Find the intervals which the function is increasing and decreasing. They want both of them. Usually I just ask you one question. What's the intervals that's increasing or something like that? Make a multiple choice question or something. Here we go. Intervals of increase, decrease. First thing you're going to do is do what? Being a calculus class and all. Take derivative of it. You got it. So f prime of x. Now look at this function. It is 2x plus 3 squared. What rule do I use to take derivative of this thing? Chain rule. Derivative outside, inside stays the same time derivative inside. Derivative outside, the 2 pops out front. The inside, 2x plus 3 stays the same. Raised to the first power times the derivative of the inside. Derivative of 2x plus 3 is 2. I'm going to clean it up. So f prime of x is 2 times 2 is 4 times 2x plus 3. There's my derivative. Now I'm going to set him equal to 0 to find where the tangent line is horizontal, basically my 0 points. And then I'm going to put those on the number line and then do test values around it. So I'm going to divide both sides by negative 4. divide both sides by 4, gives me the factor 2x plus 3 equals 0. I'm going to subtract 3, gives me 2x equals negative 3. And then divide by 2, I get x equals negative 3 halves. Yep, they're starting to throw fractions at you. Yay. Okay. Negative 3 halves. So I'm going to draw my number line. And on my number line, I'm going to put negative 3 halves. Now I'm going to do test values, quote, around this derivative. This is my derivative, so this is my f prime function here. Number line, pick a number less than negative 3 halves. Negative 3 halves, same thing as negative 1.5. So less than that, I choose like negative 2. So f prime of negative 2. This will be plugging it into my derivative right here, which will be 4 times 2 times negative 2 plus 3. That'll be 4 times 2 times negative 2 is negative 4 plus 3. Negative 4 plus 3 is negative 1 times 4 is negative 4. I don't care what the number is. What's the sign of it? Negative. So everybody in that interval is going to be negative. Now I'm going to pick a number greater than negative 3 halves and use your brain. What point will I choose? Guaranteed 0 when I have a choice at it. So plugging in 0 would be 4 times 2 times 0 plus 3. 2 times 0 is 0, so you get 4. 0 plus 3 is 3. And 4 times 3 is 12. I don't care what the number is, it's positive, so everybody in this interval is going to be positive. So, again, answering their question, they want to know, and I'll just put it over here because I got some space for it. They want to know the intervals of increase, where's this function increasing at, and the intervals of decrease. To increase means my derivative is greater than 0, and the derivative is greater than 0 from negative 3 halves to infinity. And it is decreasing between negative infinity to negative 3 halves, using famous interval notation. And that is my solution. Does that make sense? Did I lose you guys anywhere? Well, how bad can it be? I don't know. Turn page, find out. All right. Same directions on this stuff. Find intervals of increase and decrease. First thing I'm going to do is, and again, well, now at this point, we're beginning to practice. So I'm going to speed it up, and remember, I'm doing the same thing every time. So to find the intervals of increase and decrease, first thing I'm going to do is take my derivative. Derivative of x cubed is 3x squared minus, the derivative of 3x squared is 6x minus, derivative of 9x is 9, and derivative of 12 is 0. There's my derivative. I'm going to set it equal to 0 and solve. I'm going to factor a 3 out of it. That leaves me with x squared minus 2x minus 3 equals 0. And then I'm going to factor it. Let's see, what times what is 3? That differs by 2. X got to be 1 and 3. Because middle term is minus, it'll be minus on 3 plus on the 1. And then I'm going to set each factor, now that I got it multiplied, see each factor that has an x in it equals 0 and solve. So x plus 1 equals 0, and x minus 3 equals 0. Subtract 1 from both sides, I get x equals negative 1. And add 3 to both sides, and I get x equals 3. These are my 0 points. The points where the derivative of the function has a horizontal tangent line, the slope of 0. So these are my 0 slopes. I'm going to put it on my number line, and this is a derivative number line here. I'm going to put in order, negative 1 and 3. So this is a number line, so make sure you put the numbers in order. How many times I've seen students put the 3 here and the negative 1 there, and they can't figure out what the problem is. So put them in order, it's a number line. Okay, and now pick a point in each interval. Pick a point less than negative 1, I choose negative 2. So f prime of negative 2 would be 3 times negative 2 squared minus 6 times negative 2 plus 9. Negative 2 squared is 4 times 3 is 12. A negative 6 times a negative 2 is a plus 18 plus 9. 12 and 18 is 30 plus 9 is 39. Don't care what the number is, it's positive, so everybody in this interval is positive. All right? Pick a number between -1 and 3. Guess which one I'm going to use? You got it. Plug in 0. 0 is in that interval. And when I plug in 0, that's 3 times 0 squared minus 6 times 0 minus 9. That's equal to -9. It's negative, so everybody in that interval is negative. And pick a point bigger than 3. I choose 4. F prime of 4 is going to be 3 times 4 squared minus 6 times 4 plus 9. I should be minus 9. I don't know where plus 9 came from. Minus 9. And 4 squared is 16, and 16 times 3 is 48. Double check my math. 16 times 3 is, yep, 48. Minus 6 times 4 is 24, minus 9. 48 minus 24 minus 9 is 15. I don't know, this should have been a minus 9, shouldn't it? Okay, minus 9, and that would have been what? 21 or something like that?
It's not a principal.
Let's see here. No, see, plug it in here. All right. -2 squared is 4 times 3 is 12. I can do that one. -6 times -2 is 12. I jumped the gun there. Plus 12. It'll be plus 12, and then it's minus 9. So this gives you 24 minus 9. I was doing math too quickly. 24 minus 9 is 15. All right, 15. And when I plugged in 4 over here, I got 15. My point is, it's still positive. So even though I made a careless error, didn't mess up the problem. As I get looked out, it's still got to be positive here. So, all right, so here's my answer. Where is this thing going to be increasing and decreasing? I'll put it up here. My function is increasing on the interval between -infinity to -1, union 3 to infinity, and it is decreasing on the interval between -1 and 3. And again, just keeping an idea, I'm always using open parentheses on this stuff. But look at the next one. Question? Oh, all right. Okay, so let's do one more and then I'll do it. So we were trying to pass back the test, but it won't take me long to pass back the test after you guys jump on it. Well, look at this guy here. This is our first rational function. We'll do more of these guys next time. But look, this is my first rational function here. I've got x cubed plus 16 over x. Because it's a rational function, the first thing you got to do, first thing you want to do is take the derivative of this guy, right? And what rule are you going to use? Quotient rule. Quotient rule. Derivative of the top. What's derivative of x cubed plus 16? 3x squared. Okay, derivative of the top times the bottom x minus the top x cubed plus 16 times derivative of the bottom. Derivative of x is 1 all over the bottom squared. Derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. But now you're going to start cleaning this stuff up because, I mean, even in chapter 3.1, 3.2, and 3.3, I didn't say don't worry about cleaning it up. But now we're applying this stuff. You got to clean it up. This will be 3x cubed minus, and this negative is going to distribute here. So it'll be minus x cubed minus 16 divided by x squared, which gives you what? 3x cubed minus x cubed is 2x cubed minus 16 over x squared. You with me? Now, you've got to find two different points because we have a fraction. I'm going to set where does not exist at? It's when the denominator is equal to 0. So x squared equal to 0 means x equals 0. That's going to be my first point because that's the point that does not exist. And I'll label that as the D and E point. I took the denominator and I set it equals 0. Now for the 0 part, I'm going to take my numerator, which is the 2x cubed minus 16, set it equal to 0. I'm going to add 16. That gives me 2x cubed equals 16. Then I'm going to divide by 2. It gives me x cubed equals 8. And what kills off a cube? Cube root. And what is the cube root of 8? 2. Now, just to let you know, this is an odd root. You don't do plus or minus on odd roots. You only do plus or minus on even roots, square roots and the like. Okay? So the answer is 2. So I got two numbers here. I have got 0 and I've got 2. And this is my derivative. And this is my cleaned up version of my derivative right here. This is the guy I'm going to plug into. So, picking a point, just to go quickly here, I'm going to plug in -1. I'm plugging -1. -1 cubed is -1 times 2 is -2, minus 16 is minus 18 over. -1 squared is 1. That's -18. It's negative. Pick a point between 0 and 2. You know which one I'm going to use. 1. Plugging in 1. 1 cubed is 1 times 2 is 2. 2 minus 16 is -14 over 1, which makes it -14. It still's negative. It didn't change signs. I know you guys, there's a pattern every time. No, it's not. Now pick a number bigger than 2. I choose 3. And plugging in 3 into this thing, 3 cubed is 27 times 2. 27 times 2. Minus 16. 27 times 2 minus 16 is 38. Divided by, here we go, plugging in 3. 3 squared is 9. 38 divided by 9, who cares? It's positive. So everybody's positive. So what is my answer to this problem? Where is it decreasing at? It is decreasing on the interval between -infinity to 0, union 0 to 2, and it is increasing from 2 to infinity. Notice I had to skip over that 0 point. But we'll finish up this last problem next time, and it's a kind of a word problem on the old application there. But I do want to take the last seconds and actually pass back the test. So hold on for just a second and we'll do that.